Hi friends, today I offer a device with the same functionality, but assembled from prefabricated models, because I received feedbacks that some people are having problems to assemble the previous circuit. So let's look at the necessary components. Links to buy all components is under video. Step-up DC-DC converter based on the MT3608 chip. The charge controller for lithium batteries with protection based on the TP4056 chip. Li-ion battery as power supply. You can use any which to fit in the box. In my device, I use 3 9mN battery, AAA size, connected in serial. The box of the Chinese power bank, which cost $1. Mini digital voltmeter. My item measures up to 32 volt and has only 2 wires for connection. It shows the voltage directly on the power supply. In our case, it will be connected to the zener diode, but we must remember that the voltmeter itself consumed some current. Wherefore, not to overload the zener diode. It is better to use a voltmeter with 3 wires, 2 of which are for supply and the third for measurements. My easily could charge to the 3 wire, because the manufacturer simply connected measurements input with a plus of power supply. So I can separate and solder additional wire. You can buy the right version with 3 wires. Link to store is under video. By the way, for such voltmeters need a voltage of the least 4 volt to run correctly. They have measurements range from 4.5 to 32 volts. In the scheme, the voltmeter is powered directly from the converter output. It can be concluded that the device will measure the zener diodes with voltage no more than 30 volt. Switch to turn on of the device, amperage value not critically. The electrolytic capacitor of 10 to 47 microfarad, 50 volt. It is connected to the output of the converter to smoothen fluctuations. This is required for connect operation of the voltmeter. The low power resistor to limit the current through the zener diode. When calculating the resistor value, few points should take into account. In my case, it is 2 or 2.2 kilo ohms, 0.25 watt. Socket for integral circuits in DIP8 or 14 or 16 housing, where a tested zener diode will insert it. Thus, the MT3608 unit can output the voltage about 28 to 30 volt, but it can be raised up to 40 volt. To do that, a fixed resistor of 2.2 kilo ohms in series with the trimmer may be replaced by a jumper. Input of the converter fed about 4 volt, simulating the connected battery. To the output connect a multimeter. Rotate the trimmer counterclockwise. To the first 10 rotations, converter doesn't respond, and only then beginnings to increase the output voltage. We can quickly put the output voltage up to 35 volt and then must rotate very carefully and slowly until get to 40 volt. Don't exceed 40 volt, because current consumption increases and the chip will burn. But still, I do not recommend it to do this remake, because the converter will become unstable. It is better to leave as is, i.e. 28 to 30 volt output. Now bend socket pins and solder them together on every side. Assemble the scheme as shown. The switch set on the side panel, socket and voltmeter are located on the power bank's back cover, which has now become the front. That's I have as a result. All neat and works fine, plus charged from USB. Now let's speak about possible replacements. The power source may be any voltage higher than 3 volt, since the device consumes scantily currents and designed for short-term work. Even the usual 8-volt battery will work for long enough. As mentioned, I used the Ni-Mn battery. Putting a special charger for them doesn't make sense, because they aren't as critical to charge as a lithium. The voltage of 3 Ni-Mn1 is almost equal to 1 Li-ion. And now let's test device. As you can see, it's okay. If you like it, thumbs up. Thanks for watching. Have a nice day.